Okay, let's come back to the eigenvalue session. Last time we've talked about the calculation of eigenvalues. So now, as mentioned in the very last, at the very end of the last episode, I said that we're gonna move on to MATLAB. So let's just move on to the MATLAB. Here in MATLAB, let's just put in the matrix A. So I'm just going to use the matrix A that we calculated in the lecture. So it's uh, 3 minus 1, 0, 1 minus 1, 2 minus 1, and 0 minus. So it's 3 minus 1, 0, minus 1, 2 minus 1, and then 0 minus 1, 3. So this is matrix A. Actually, in MATLAB, if you say, E equals to EIG of A, the function EIG is for calculating the eigen. So if we just run it, first let me just set this to be, instant EIG for IUP. And when I said instant, that means, it's the instant function that's already built in MATLAB. So you can just use it for just to get the eigen of the A. So if I type E, which is the output, equals to EIG of A, so let's see what my E is. So my E is a vector containing 1, 3, and 4. So if you take a look at the lecture last time, we've got the eigenvalues to be, here. The eigenvalue is 1, 3, and 4. So basically, E contains the eigenvalues of the matrix A in a vector, right? Actually, there are many ways that you can use the function EIG. So if you type help in MATLAB, help can give you the guideline of how to use each function. So if you want to use how to use EIG in MATLAB, you can just type, help EIG, and then you hit enter. Hang on, it said easy here, so okay, here you go. So you're going to get a lot of guidelines of how to use EIG. For example, it said here that EIG is the eigenvalues and eigenvector, okay? So if you just have one output equals to EIG, that's going to give a column vector E containing the eigenvalues of the square matrix A. So this is what we got here. So the output equals to EIG, so it's the column vector containing the eigenvalues. If we just type two outputs, one is a V, the other one is the D, equals to EIG, to just copy and paste. Let's see what we're gonna get here, okay? So V, comma D, and equals to EIG, and I just run it. Okay, now let's just see my D dog first, the capital D output. So for the capital D, this is actually, a matrix of which the diagonal contains the eigenvalues. For me, I don't really like this type of eigenvalue that much because I just want to know the values of it. I don't want to have it in the matrix form. But this is one option that you can have. Let's just see the V here. So V here, my claim is that each column, so the first column, this is going to be the eigenvector of the first eigenvalues, the first eigenvalue in D. For the second column, the value in the second column, minus 0.7071, 0, and then 0.7071. This is the eigenvector for 3, the eigenvalue of 3. And finally, when the eigenvalue is 4, the eigenvector for the 4 is the last column here. But you might be wondering, okay, so I know that, the first eigenvalue when it's equal to 1, then my eigenvector has to be like that, 0.4082, 0.8165, and 0.4082. But when I did my calculation last time we calculated the eigenvector, right? This is what we got. Well, actually, it's 1 to 1 times A. And if you take a look at this, this is actually just the number in the second row is just the double. It's just double of the number in the first row and the last row, which is pretty much, the same as vector x here. That just change the value of A, right? But why did MATLAB give me this number? Well, actually, MATLAB normalize the eigenvector that it shows. So in MATLAB, the function EIG provides eigenvector that are already normalized. So whatever number that you've calculated, MATLAB is going to do something like this. So my x, whatever x is, just going to be equals to x divided by the norm of x. This is the norm of x. This is actually a Euclidean norm. So x divided by the norm of x, let's just see here. Sorry. Here, let's just put x equals to, let's just assume that a is 1. A can be anything. So if we assume that a is 1, then x is 1 to 1. So let's just say, if I have my x equals to 1 to 1, okay, and then if I say y, or just x equals to x divided by norm of x, so this is my x that I have. If I have any x and it's divided by the norm of x, this is going to be my output, which is going to be the vector provided by MATLAB. So as I mentioned, the eigenvalue provided by MATLAB is just the vector that is normalized. Okay. Another option that I want to talk about in using the EIG is that you can also do something like that. Okay. If you say, V and then maybe letter D equals EIG of A, let's see what I'm going to get. Oh, okay, forgot. And I also have to say here, vector. The term vector here is just, an input argument. And let's see what I'm going to get here. So if I run it this way, my V is going to be the same, which is going to be the matrix containing all the eigenvectors for the first, second, and the third column. And then let's just see my little d here. So my little d is just a vector containing all the eigenvalues. So rather than having the capital D, which is a big matrix containing the eigenvalues on the diagonal line, I just say here that I want the D to be in the form of a vector. So this is what I'm getting. So these are mostly the things that I've used for the function EIG. So you guys might want to explore around. But don't forget to use, help when you in need of something, or when you are wondering what you can use about the function in MATLAB, or just say, log, and then MATLAB can pretty much give you the guideline of how to use it, and then a good explanation about it. Okay, so for using the EIG, I'm just gonna stop this clip for now. It's gonna be a very short clip. Next topic, I'm gonna talk about the power method.